In the previous video, we covered constant acceleration, which gave us uniform motion and uniform acceleration. Continuing on with our discussion on motion along a straight line or kinematics, let's now have non-uniform acceleration. When the acceleration is not constant, the object is said to be undergoing non-uniform acceleration. For non-uniform acceleration, you go back to the basic definitions of acceleration and velocity. A is equal to dv over dt and v is equal to dx over dt. A is equal to differentiation of velocity with respect to time, and v is equal to differentiation of x with respect to time. A problem of non-uniform acceleration will typically provide an equation that is describing the motion of the object. This is one big difference between problem of uniform acceleration and problem of non-uniform acceleration. If you see the problem provide you with an equation that is describing the motion of the object, in all likelihood, the problem is one of non-uniform acceleration. And depending on the situation and what is being asked for by the problem, you might have to differentiate or integrate the provided equation. If you have an equation of x and you are looking for v, you differentiate x equation. With respect to time, you get the equation for v. And if you have the equation for v and you are being asked for acceleration, you differentiate the equation of v with respect to time and you have the equation for a. And for the reverse, you are given equation of a and you are being asked for v, you integrate the equation of a to get the equation of v and so on. And to illustrate that, consider the following example. You have the following problem. The position of a toy car is found to be described by the following equation. You are given x is equal to negative 5t cubed plus 4t squared plus 6, and the unit of x here is millimeters. Determine the displacement of the toy car from t is equal to 2 seconds to t is equal to 5 seconds. And you have a second question, what is the acceleration at t is equal to 5 seconds? So first, considering letter A, the first part of the problem, determine the displacement of the toy car from initial time to final time. Since we already have the equation for position, all we need to do is determine the initial position and determine the final position. To get the initial position, you plot in the initial time t into the equation of x, and that will provide you with the initial position x1. x1 is equal to negative 18 millimeters. To get the final position x2, you just plot in the final time t is equal to 5 seconds into the equation of x, and that will give you the final position x2. x2 is equal to negative 519.0 millimeters. Displacement is final position minus initial position. So, negative 519 minus negative 18 that will give you negative 501.0 millimeters. So you have the displacement delta x is equal to negative 501.000 millimeters. For the next part, letter B, what is the acceleration at t is equal to 5 seconds? You are provided with the equation of x. We need to get the equation for A. To get the equation of A, we need to differentiate the velocity equation. To get the velocity equation, we need to differentiate the equation for x. We have the equation for x. So differentiating this with respect to time will give you negative 15t squared plus 8t. And then differentiating this with respect to time, we get the equation for acceleration. Negative 30t plus 8. Now that we have the equation for A, all we need to do now is plot in the value of time. T is equal to 5 seconds. And that will give us the acceleration at the 5-second mark. A at the 5-second mark is equal to negative 142.000 millimeters per second squared. So please take note of the units. That's very important. And that's it for now. That's it for non-uniform acceleration. In the next video, we'll continue our discussion on motion along a straight line. In the next video, we'll take a look at the concept of free fall motion. So thank you for watching.